So 27 is 9 minus x divided by the square root of x minus 3. Perfect. So 27 is a slightly different situation because remember last time we looked at three functions. I'm glad that I didn't throw this away. So we looked at polynomial, we looked at radicals, and we looked at rational. Okay, this is a combination. This is not a pure function because it has a combination of a rational with a square root. Regardless of what the function looks like, we still have to find the initial assessment. Can anyone give us the initial assessment?
Nine minus 9. We're just plugging in x, correct?
Right, perfect. Which is? Yes.
9 minus 9.
Which is?
Over 1. 0.
Good. Over?
Square root of 9 minus 3.
Good. Which is?
0.
Perfect. Yay! There is hope. Okay. Good. So now there is a procedure that we have to use that you may remember or you may not remember. I'm going to explain it again. Rationalize the denominator. Sometimes we rationalize the numerator, but we have to rationalize the denominator because that's the one that has a radical. Rationalize the denominator. Anyone remembers how we rationalize the denominator? So I'm going to leave it alone and copy it and start from scratch. X approaches 9, 9 minus x, the square root of x minus 3. Here's the hint. What do we need to multiply and divide by? Anyone remembers? It's okay for
reciprocal?
yes, yes, not the inverse. Careful. The inverse. So the inverse of 5 is 1/5. That's the multiplicative inverse. Okay, so it's called conjugate. So if I have the square root of x minus 3 here, I need the square root of x plus 3. But it has to be top and bottom because this must equal 1. I cannot change the function. But multiplying it by 1 is not going to change anything. So now I continue here. So I have limit. Notice that I cannot drop the limit operator till I apply it. I did not apply it yet. X approaches 9. I'm going to put this in the correct order. It's not in the correct order. It should be negative x plus 9. And now I don't like it because it has a negative leading coefficient. I'm going to pull out the negative leading coefficient. Times the square root of x plus 3. Now the key is to multiply these two. And we did this on the first day. How do we multiply a minus b times a plus b? And what do we get? A minus b times a plus b. Anyone? We did this on the first day of classes. Somebody asked me, please show those 3 formulas, actually 2 formulas. And we experienced this one and we played with this one on the first day. Can anyone tell us what to write here? A minus b times a plus b. What is the formula?
The difference of squares.
Yes.
A squared minus b squared.
Excellent. Please square this. Excellent. Please square this and tell me what to write. Please square this and tell me what to write.
Sorry?
Please square this and tell me what to write.
x.
Yes. Then you said minus. Please square this and tell me what to write.
9.
Exactly. So the trick here is, most of the time, and I cannot give a recipe, okay? Factor and simplify. That's the key in 0 over 0. Good. Nice. Awesome. Can anyone, so let me write it again. So this is limit as x approaches 9 minus the square root of x plus 3 divided by 1. I shouldn't even write anything. But, okay. Please plug it in and tell me what you get. That's when my markers are getting dry, because I'm waiting for my students to say something. A student, when I said that one, said, yeah, you're cheap markers. I said, yes, they are cheap. So my cheap markers are getting dried out. So what do I write? Please, anyone? I'm applying the limit operator, and I need an answer.
-6.
Thank you very much. Who said that?
Samantha.
Thank you. That's it. -6. The square root of 9 is 3. 3 plus 3 is 6. 6 with minus in front, -6. Awesome. Okay, let's look at one.
From that again, like just because like I feel like I got lost when you after you rationalize the denominator. I don't understand what that second part, like the very middle of the sheet. I don't understand what you did there.
This one?
Right above that.
Here?
Yep.
So when we rationalize, we multiply and divide by the same quantity, because this is 1. The square root of x plus 3 over the square root of x plus 3 is 1.
Okay.
These two, you have them here. You see those two here?
Yep.
When we multiply these two, we use the formula from the first day of classes. A minus b times a plus b is a squared minus b squared.
Right. Okay. I just didn't understand what you were doing in the middle.
Is that okay now?
Yes.
Good. So now these two go away. I wrote 1 because if I don't write 1, some students say that's 0. No, it cannot be 0. X minus 9 simplifies with x minus 9. I copied again the same with the remainder, whatever was left, I copied it here. Now this is the time in which the limit operator is applied and it disappears. It cannot disappear till I apply it. I did apply it now. The limit of this, when x approaches 9, is -6. Is this okay? Anyone? Okay, so now we have to look at one more situation. So please choose from 31 through 40. And this one we already discussed, but we will choose one from here, and then we can move on. Can I choose? I will choose 35, if you agree with me. Nobody said anything. So do you want, is that okay with 35? Do you want to pick another?
That's okay.
Okay, so we have limit as x approaches infinity from x squared plus 2x plus 5. Everything, no, not, it's 3. Over 3x squared plus 5. Okay. We're asked to find the limit. What is the first step we need to perform? No matter what it is, no matter what the answer would be. What is the very first step, always and forever?
I'm gonna say factor.
Although there are some exceptions. So I said always and forever, but there are some exceptions. So first of all, we have to plug it this in to obtain the initial assessment. Okay, wait a minute. So that's what we did here. I had to plug it in to get the initial assessment. Here, I plugged it in and I got a number. Done. I don't have to do anything else. Here, I plugged it in, I got a number. Done. I don't have to do anything else. But in the situation of 0 over 0, I had to work hard. Who knows what this is? I have no idea. So I need the initial assessment. And in step number 2, decide what is next. Here, I made a decision. Nothing. Here, I made a decision. Nothing. No decision. It's done. There is nothing that I need to do next. But here, I had to make a decision. What do I do next? Oh, okay. I look at this. I have to rationalize the denominator, blah, blah, blah. Factor and simplify to get to the answer. So that's why first step is always plug it in. Again, to be exact, there are some exceptions. But for us, in this class, we will always have to plug it in to see what it is. Okay. So the previous situations were nice and easy. I had to plug in 9. How will I plug infinity in here? Very simple. I'm going to ask you from these 3 terms, which is the most powerful at, I shouldn't cover it, at infinity. Which of these 3 terms is the most powerful? Well, actually in general, but especially for infinity. Which is the most powerful one?
X squared.
Of course. Where I'm missing my props. Where are my props? I don't know. I'm missing my props. Okay, so the top. So now that's all I need to think about. Infinity squared. What do you say? What will that mean?
All real numbers. I mean, basically anything bigger than 0.
But it's infinity. We're not talking about something greater than 0. We're talking about infinity squared. What do I get when I square infinity?
Infinity.
Thank you. Same situation here. This is the most powerful one. When I square infinity and then multiply by 3, what do I get?
Infinity?
Exactly. So remember a few minutes ago we talked about this situation and we said that it has hope. This is called indeterminate. Indeterminate case. This is also an indeterminate case. Both of them have hope. Indeterminate means I have no clue. That's what indeterminate means. Undefined means it's done, dead. But indeterminate says I have no clue. It may or may not, but it has hope. Both of them have hope. Okay. How do I address this problem? Jump over all this. So let's go back. You already told me that it happens that in both cases x squared is the most powerful one. I will factor out x squared. They're not related. It just happens that the denominator also has the same degree. And I know you're going to scream, and you should scream, and say, you can't factor out x squared. X squared is not a factor in these 3 terms. And I will have to say, absolutely right. It's not a factor. But I have no choice. I have to factor out x squared. Okay, fine. How many terms do we have here? How many terms do we see here?
3.
Excellent. How many terms do we see here?
2.
Excellent. So then here I have to have 3 terms, and here I have to have 2 terms, such that x squared times the first term is x squared. X squared times the second term is 2x. And x squared times the third term is 3. So x squared times 1 will be x squared plus x squared times 2 over x will be 2x. And x squared times 3 over x squared will be 3. X squared times 1, x squared. X squared simplify 1x, but 1 is still left in 2x. X squared simplifies with x squared, and I get 3. So what I'm telling you is that you can factor out anything you want from anything you want, anything you have. So for example, if I have x plus 5, can I factor out x to the third? Yes, I can. You can say this is insane. X cubed is not a factor here. True. But I'm going to write this. X cubed times x squared is x. And I'm going to write this. X cubed times 5 over x cubed is 5. So you can do whatever you want, meaning you can factor out whatever you like. Here I have to factor out the degree. I have to factor out the degree here as well. Can anyone try to give us these two terms? It's okay if you're wrong. Here I only have 2 terms to write because that's what I have here, 2 terms.
Would it be 3 plus 5 over x?
If I write just 5, yes! Excellent. Excellent, excellent, excellent. That's it. So now, of course, I'm going to do this because it's gone, x squared with x squared. And now we have to talk about something before we finish this on the side here. Limit as x approaches infinity from 1 over x. You can say, but what if it's x approaches negative infinity? The same thing. So, or negative infinity. So what is the preliminary here? And you can say you're jumping from one thing to another. Yes, just because I need to show these pieces. That's why I'm doing this. And I'll come back in a second. So, preliminary. Where is the numerator going when x approaches infinity? It's just 1. There's nothing, I cannot plug in anything. Where is the denominator going when x approaches infinity? You're going to say, what are you talking about? It's infinity. So what do you think the answer here is? I have imagined that I have a pie. And I want to share it with everyone in the US. So I give a piece to the first person, I give a piece to the second person, I give a piece to the third person. When I knock on your door, I will eventually get to your door. How much is left from this pie? 1 divided by infinite. 1 pie divided by infinitely many people. How much will everyone get? If I want to share it equally with everyone in the US, 360 million. How much will everyone get? I have to divvy it up. I have to divvy it up in infinite. How much will you get?
Infinite.
So I have $1. Forget about the pie. I have $1. And I want to share it with everyone on the planet. When I get to your door, and I knock on your door and I say, I'm here, I want to share what is left from the $1. How much will you get from it? $1 divided by infinitely many people.
Would it be just 1 over infinity?
Which is?
Infinity.
I wish. So if we split $1 into infinite many people, everybody will get millions and millions and billions of dollars. How much will you get? Okay, So here's another example. I have a tissue. And I'm going to take a little piece, I'm going to take a little piece, and I'm going to take a little piece. And I want all these pieces to go equally to everyone in the US. When I get from this, when I finish dividing it, and so that everyone gets a share, how much will everyone get from it?
An equal amount.
Yes. Okay, so let's divide. Here's another example. $1 by 360 million people. Do I have enough zeros? I have enough zeros. This means, where is my camera? This means 2.7 times 10 to negative 9. 0.802777. So the answer from my calculation will be 0.123456789 From my dollar, every person will get in dollars, right? 0.00000000277. Are you a millionaire from this? So what is the answer when I divide 1 by millions and millions and billions?
0.
Thank you. 0. Nothing. Nada. Nothing. Nothing. Absolutely nothing. 1 divided by huge is nothing.